So, for the people that I hear asking the random question, why does it smell good? Normally, Mrs. Goldring would be the reason why it smells good. It's probably not me, I guarantee that. Unless I've just put on new deodorant, and then it might be me. So, not necessarily new page. Sorry, I keep trying to say new page. Please get out either your notes that you're going to continue, or a new page of graph paper. I do have a lot of homework to pass back to people, but I'm trying to find a good time during class to do that. Please pay attention to math. Some of you guys have some missings from me. Casey, where are you going, dude? Okay. So please check math. If you have a missing for me and you don't understand what you need to do, please come see me. I will be able to specifically tell you. I have a spreadsheet where it's all organized, and I know exactly what's up. Yeah, let's head our notes for today. So I'm going to flip screens here. Today, our main topic that we're going to talk about and solve problems on is converting those fractions into percentage values. So let's head our notes with 1, 2, 4. Make sure you have a date on there. What's today's date? 9/5. 9/5. 1.2.4. I know topic is over here, but I have more space right here. And honestly, if you want to make your life easy, we could do fractions and then an arrow percents. Because what we are going to do is practice taking a fraction and turning it into a percent. So for those of you that might end up here tardy, like late for class, I'm going to pick on Kevin because he just showed up. If you ever miss the homework being up there, it's always over here. Okay, so if you can't see from like that side of the room or whatever, get it at some point later. AO extensions. If you missed today, I see some people like straining to look at it. It's just 1994 in the 1.2.4 lesson, of course, because our homework's always based off the lesson we did. Like I have our homework is 1994, also over there. I know sometimes Creative Start gets out late, but sometimes it's just you guys hanging out in the locker bay, so please try to hurry and get down here. And yes, they did fix the air conditioning. So yay them. Yay for people that know how to work on air conditioning. So, actually, do I have anyone that wants to read? Go ahead, Aiden, read that top paragraph.
Okay, in the last two lessons, you have been working with fractions and percents to represent probabilities. In this lesson, you will use geometric strategies to further your understanding of how to convert fractions to percent and to model the probability.
Conversion.
Learning the geometric strategies will give you a deeper conceptual knowledge of connections between these different
representations. Yeah. A lot of huge words here. So conceptual, and actually I should pull this down because people watching the video at home would not get this. Conceptual means you understand a concept. So concept is the idea behind how you do something. So having a deeper conceptual knowledge means you actually understand like how and why we do something. So again, let's write in our notes a reminder for us what percentages really mean. Who can remind me what percent means? And if no one can, then that's a problem. But we're going to put a hyphen here, actually. So please write down your notes, percent. Sky? Yeah. Yeah, per 100, or out of 100, or over 100. Per really means for every. So I talk about 2 cookies per kid, 3 waters per person, 1 pizza per Mr. Hudson. It really means for every. Because I'm a teacher. And cent, century, cents in a dollar, always means 100. Centimeter, 100 centimeters in a meter. So in 85, please label, we're moving on to 85. We're flipping coins, and if we actually do it, right, we flipped the coin 25 times, what probability is that? Anybody? Or, sorry, not like what is the probability. Is it theoretical or experimental if we actually flipped the coin? Experimental. Experimental, yeah, we did it. So, yeah, that pause was long enough to make it awkward. It is experimental if we actually do it. So check this out. After 25 flips of a fair coin, fair meaning it's not rigged or weighted or anything like that, Lorraine had 14 heads. So our first question I want you to discuss with your group, is this more or less than what we expect? Right? What we expect is that 50%. That's our theoretical probability. So how does 14/25 compare to that percent? And one way that you can compare that is to calculate it. So I don't really care what order you do this in. You don't really need to label A or B. If you can go ahead and calculate 14/25 into percentage, do that. I'm going to give your group probably about 90 seconds to see what you can do on this. So try to turn 14/25 into a percent and compare it to 50%.
You were behind me. Scared me. I never do anything. My mom does that all the time and it never works. Yeah, nothing ever works.
Guys, one of the first things we should have set up is that 14/25 that they give us. So as I walk around, what I'm looking for is, do you even have that set up initially? Nope, write it. Gotta see how the work happens. Now a couple of you, and I'm real curious how, so Eva, when I look at your paper, you had something interesting drawn. Do you know the name for what you have drawn on your paper for that conversion?
The big one.
Yeah, the big one or the giant one. So when I draw those arrows, there's another method that CPM uses to really represent what we're doing. We want to get 100 on the bottom, right? So that's my goal. Go ahead and set that up. If you don't have it set up, set that up on your paper. To do that, we're going to multiply by...
No.
Did you guys do this in 6th grade?
No.
Hey, stop. Hey, did I say you have to do this?
Maybe.
No! Chill. All right? Chill. I get it. It's kind of hot in here, but chill. If this makes sense for you, wonderful. True honesty, I don't use it. True honesty, no one ever taught it to me. But what are we going to do to get 25 to turn into 100? Everybody, anybody. Multiply by 4. So we put 4 before. That's really 1. And we can get, what's here? 56. Now hold on. Is it 66? No, it's 56. Do chill. Let's mathematically figure out how this makes sense. Now, hold on. Stop. I love the argument. But Joey, you have your hand up.
Yeah, I did 14 times 6. Here, let me check. I think I did it wrong.
Check it.
Sorry, 14
If you're part of this argument, you better be paying attention. I'm going to break up 14 because, I'm scared of big numbers. What is 4 times 10? 40. What is 4 times 4? 16. 56. Okay, break it apart. So, really how I do this, you can use the giant one if you want to, but the other way, what I'm looking for on your paper, so please practice it in class because it's what I'm going to look for on your mastery, is showing what you're doing. So if you start with 14/25 and you just want to turn it straight into 100, you can't. You don't have to draw a giant one, but what I need to see are these arrows going from top to top and bottom to bottom, and then at least one of them needs to show me what I'm doing, like what I'm multiplying by. This is perfectly fine if that's how you want to do it. Now, you could write the times 4 up here as well, or you can just remember that if I do it on top, the same is happening on bottom and vice versa. So, means backwards, like the other way around.
You said vice versa.
Yeah,
It's vice versa.
depends who you ask. Depends who you ask. Any questions on that? So we all have the work written for this problem. Move on to 86 with your group. Be ready. I'm going to use random cards on this. Be ready to explain why this works. So check out. I'll drag it down. Damar.
Whatever.
What were you reading?
Here, come here, Casey. Okay, is that what's really happening, or have you not done it? So, you have till Friday to get your work, or we contact your parents. Okay, because if you are already like avoiding your work at the beginning of the school year, that's like really bad. We need to get it figured out. So either handle it on your own, like in the first 7th grade, or conference with your parents and start checking your phone book every day. It gets a lot more uncomfortable. Okay? I don't really want to do that, but I'm real worried that you're way behind. You're missing like 7 things. Lovey, can you explain? Because people moved, and I don't know where people are. So my brain has a really hard time when I'm not gonna not move you just because like whatever. I don't like when people get bored of where they're sitting or whatever else. So like my brain's confused. It's gonna take a couple days for me to figure out where you're all sitting.
I'm over here.
So, Laviva, can you explain to me what's going on here? Pass. Eva, nah, we just talked. Sorry, we'll skip that for now. Madison, where's Madison? Madison, what is going on here? Can you explain what the picture shows? We're all passing for this. Fine, I'll look for volunteers. Anyone volunteer for this?
Nope.
Guys, do you know what's going on? What's going on? Can you explain? Okay, well, I mean, how do we get there? Like, what did he do? What does this picture show? Yeah, to get 100 pieces to actually talk about, we got to multiply by 5. So visually, what Damar has done here is he said, well, if this is 20 blocks, I don't know why you're doing that. Yeah, something happened with my Smart Ink. I need to update something. I can't write on here. If this is 7 out of 20, I got to make 5 sets of that. So show that on your paper, put the 7 over 20, and then show the math to get 100 on the bottom. And if we multiply by 5 on bottom, where else do we have to multiply by 5? Top. So we have 7 out of 20. This is from 86 we should have labeled. Multiplying by 5, yeah, be careful with that 7. 7s are sometimes tricky for people. 35. And make sure you then write that it's 35%. We're not just trying to get to the other fraction. We're trying to, in the end, get to the percentage. Does this make sense? Because, okay, so I don't like springing things on you guys. We will be having a mini mastery on Friday. So, like a small test, like a quiz. What's going to be on it is perimeter and area. Same stuff you've been doing in a lot of your practice. Simple probability and conversions, right? Converting fractions into decimals. That's it. So that's all. Like we're doing small amounts, chunking things out. In case you try to get this word caught up, I think you can probably copy off Kevin. Do this to 3/10.
Wait, do it have to be out of 100?
Well, if I'm going to get 2%, does it have to be out of 100?
Oh, yeah.
No. Wait, no. That would just be 3%, right?
Not 3%.
30%.
30. Because we have to multiply by 10. So show this.
It is 30%.
30 over 100. 30%.
I like this.
It's so simple.
Easy, right? It's well, and okay, so easy is relative. We haven't really had this conversation yet, but be careful when we're all together, or even when you're working with your friends. If like I think something's easy, that doesn't mean I feel as if you should think it's easy. Just I think this strategy, which people didn't teach us like this back in the day, this is super easy because if I can just make the bottom 100, the top tells me what the percent is. Yes.
Is that why my dad thinks that he knows what I'm doing in math, but really he doesn't?
Well, he probably knows what we're doing, but maybe not how to get, like, how to take the same route that you're taking. So you both probably end up at the same location. So here's my analogy for this. Who's been to Disney? Right? I doubt we all took the exact same way to get there. Right? So my analogy for this, or maybe it's a metaphor. Hey guys, why are there like 8 people talking at the same time as me? Check yourself. 7th grade appropriate classroom behavior. There are a lot of ways to get to Florida, which means there's not one right way to solve a problem. What I mean by that is like, all because you take a different route than me doesn't mean you're lost. It means you're just taking a different route. You're probably still going to end up in the same place. So check out 20/50ths. If we have, a fair coin, right, not rigged, no cheat, and we have 20/50ths, Randy, I have a friend named Randy, he might make this mistake, but I doubt it. Randy says 20/50ths is equal to 70 hundredths. So he puts 20 over 50. Now hold on, you're going to talk with your group, so just nobody like react out loud and get all angry or anything. So Randy says, yeah, well, to get to 100, I add 50, so I do the same thing up here, same thing on bottom and top. Talk with your group. Is this right?
No.
This is not correct. Who can explain why? Riley? The rule with what I do to a fraction, top, bottom, that only works with multiplication. You cannot apply that rule to addition. So if we are trying to compare 20/50ths to turn it in, sorry, my brain's getting confused. 20/50ths, Riley, what do I have to do? I have to double. It only works with multiplication or division, because remember, division is multiplication. Division is the same thing. So this becomes 100 when this becomes 40. So be very careful. You can only apply that rule with multiplication or division. Any questions on that? But division doesn't exist.
Can you show us the top one?
What do you mean show you the top? Oh, just scroll up a tiny bit. It was just, well, and we should probably put like an X here because it does not equal equal. This is not true. Please make sure on your notes you indicate like, that was a mistake, that was bad. Questions? In your textbook, let's say you're sick or whatever else, when you see the stoplight, that means it's like critical content that you want to make sure you understand. So make sure that right now you totally understand why this doesn't work. Like you think it would make sense if I add something to the bottom, I can add something to the top, but that doesn't keep things fair. It doesn't like keep that ratio comparing 20 to 50. You mess it up when you add things. It's not fair. Because that's essentially like saying, I'm going to add, what do you say, heads? I'm going to add, or I'm going to flip 50 more times and every single one of them is heads. Like, that's not going to happen. Unless you got a cheat coin. Check out 88. Like something that's weighted. Like you can do weighted dice. I don't. You make the two different sides out of two different metals.
Do you buy those at like joke shops?
Potentially, or like you could just have a coin that both of it is heads. Like you just have to like keep that hidden from somebody. So in 88. 3 students invented a game in which they flip coins for 1 minute and determine who flipped the highest percentage of heads. So Maria, let's put a little M here for Maria. Maria got 12 out of 25 heads. Autumn, I wish it would turn into Autumn, got 18 out of 40. And Kumar got 44%. Well, okay, so Kumar already went to 44%. Kumar just already knows. He already did the math. He's really good. So they all think they won, right? Just because they want to win. And so Autumn and Maria flipped their coins a different amount of times from each other. So we need to figure out how we can compare them in percentages of the easiest way. So Kumar's can stay. We can just leave the 44%. But I want your team to figure out what was Maria's percentage and what's Autumn's. I'll tell you right now, Autumn's is harder to figure out. And I'll even give you the hint, it might be better to go backwards with Autumn before you go forwards.
Ooh, I know how
So I'm going to give you guys at least 2 minutes, probably 2 minutes and 45 seconds if I'm honest. All right, go for it. Nice. I'm going to call on you. Can I call on you? Actually, do you want to come show it? Do you anyone want to show A? You got to have it on.
Wait, can I do B? Can I do B?
Who's already doing B?
Can I do B?
Wait, do A. Show, or not, well, sorry, not Autumn's. Do Maria, the first, I meant the first part.
Oh,
Yeah, a couple of the problems. There's always a variety of problems. You do me a favor. Fix your B. Just make it look more like B. Just to make sure that people can really read it. Thank you. If you're done with 88, I challenge you to move on to 89. I bet you can't do D.
I bet. You want to bet? You want to bet?
No, I don't actually. I hope that you can do D, because as your math teacher, I want you to solve the problem. So no, I don't want to make that bet.
I can definitely.
Sorry, it's a figure of speech. So, Biba, do you want to come do Maria? No.
Oh, I know how to do it. I know how to do these too.
Well, I already had a guy come up to you. Like, you want to do?
I don't know how to do it. I don't know how to do it. Oh, that's great.
So, autumn. Joey, do you want to explain it or do you want me to explain it? So Joey came up and he expertly showed us what to do. Joey first divided the top and the bottom by 2 to break his bottom down to 20 instead of 40. Because 40 cannot multiply up to 100 easily. Right? It can happen, but it's not easy. So Joey made his life easier. Right? Why work harder than we need to? So once he got to 9/20ths, he then could multiply by 5 to the bottom and top and make his life easy. Jalen had an easier task because 25 can multiply up to 100 easily by just using multiplication of 4. And Jalen, I love that you guys showed 2 different methods. Instead of showing the giant ones, just showed the arrow method where we show what happens on top and bottom using those arrows, getting to 48%. So who actually had the best results of head seed? Maria. Did anybody match the theoretical probability? No, because as we said, it almost never actually happens. It's very hard to get the perfect theoretical probability when you do a bunch of if you flip the coin twice, you might get 1 heads and 1 tails, and then you're like, yeah, I was successful. But I mean, like when you do a bunch of trials, it's hard to get perfect theoretical because when you do the experiment, it doesn't always happen how you think it does.
My
Yeah.
sister was doing like something for math, and it was like, so she was trying to multiply something, and I guessed a number, and it was like 1 away from the actual.
Yeah. Now, did you have some thought behind your guess, or was it a total guess? No, it was a total guess.
Yeah.
All right, try 89. I'm gonna give your group 4 minutes. I'll give you a minute for each of these.
I'm already done.
Guys, I'm already. Yes, I am, bro. You want to see all this? I'm like,
Don't show her the answer.
I'm gonna show you the answers. I was actually. Yeah. I think that's right.
We can't learn how to
Anyone want to come do A? The louder you are, the less likely it is I pick you. Eva, in the back, just nicely raise your hand, kind of smile. Hey, so do you want to change colors? Just use this top channel. So do you want to show multiplication colors? Yes. Sorry, I had to check the multiplication in my head. Yes.
Can I have White Castle?
What?
Can I have White Castle?
Merch. I couldn't understand what you said. Oh, okay, Eva. We have to show our work if we're going to come to the board. What's the point of coming to the board if you're just going to write the answer?
I did mental math.
Mental math is a great way to get a meeting with me. So no joke. Real information I want you guys to understand. When we take mastery assessments, if you do not show your work, that's a great opportunity for me to write "see me" on your paper, and we'll just talk about it. Because I gotta know that you understand the process, not just that you can get the right answer. So what'd you do on top and bottom? There we are. You can do that one before me. You want to do D?
Okay, so I'm gonna do B. B and C.
You can do B or C. I don't know either one. Sure.
B is so simple. Everybody knows B.
Wait, so you didn't answer my question?
What? Did you do Summer Smarties and win a prize?
Yep.
What's your username?
Like,
You gotta do Summer Smarties. I told you guys about it. Did you do Summer Smarties and win a prize?
no, I did. But I was honest.
I didn't win a prize.
But I was honest
All right.
about it.
So Aiden said that B I'm going to let him do B and C because he said B was too easy. Whenever we see a denominator of 10, just, yeah, it's pretty easy. Just throw a 0 on bottom and top, and what we actually do is multiply by 10 there. And then Aiden, what are you going to do in C?
I'm going to times it by 4.
We're going to times by 4. Now do me a favor, instead of using the X for the multiplication, use the dot. We very soon are going to start using X as a number that we don't know.
Like X equals.
Yeah, so we need to stop using it for multiplication and just use the
Our
dot.
teacher made us stop last year. It's weird and it
Good
lets
on
us it, and
Oh yeah, I know Mr. Green.
if we did the X, it would like give our paper back and make us do it.
That was like she never watched my class.
Oh my gosh, that is so cool.
You wanna-
Oh, this is VIP.
What are you doing?
I'll comment on your YouTube.
All right, so please check your answers. Hold up. A, 65%, B, 70%, C, 48%, and Natalie is going to do D. You don't even have C written down. There's no way I'm writing it. Guys, for what it's worth, if you are one of the people wanting to come to the board, you don't come to the board unless you have it written on your paper. So, but yeah, I mean, it works. Natalie, what are you doing first?
Dividing.
No.
Divide by 3 to get the denominator into a 10. Does the thing go in at the top or the bottom?
Not you, Natalie.
Gangster. Layla, what do you do?
She listens to like heavy rap. She likes to work out a bunch, so I think I fixed it.
Like the cardio version.
I have no idea. I don't listen to it. No, she listens to like old rap. Hey, so you have the next 8 minutes to work on your homework.
Oh,
You have the next 8 minutes to work on your homework if we make it. So here's what's up, really.
Really?
If we can get through class in an efficient manner, which means like do the work we need to kind of quickly, I want to give you guys time to work on homework. Let's see if there's anything from the homework that we should talk about together. So please make sure you have a proper header on your homework. Everyone look at 94 real quick. I can't write on this screen. What do we need? And guys, your homework doesn't have to be in order. So if you want to go ahead and do 94, like you can put that first. I just look for did you do all the problems. I don't care what order you do them in. What do we need? There's still a lot of conversation. Before I can add or subtract fractions with each other, what is it that we need? Common denominator. So, now hold on. I'm going to give you the easiest strategy here. To find the least common denominator, there's a little bit more work to do, but to just make a common denominator, here's the easiest strategy. 8 and 6 are not common, but if I multiply 8 by 6, and then I multiply 6 by 8, am I going to get the same thing? Yeah, what's 8 times 6 or 6 times 8? 48. So now my denominator becomes 48. That's 18. This is 8 over 48. 18 minus 8, 10 over 48. This can be reduced now, and this is where I'll work down to the least common denominator. What can the top and bottom both be divided by? 2, because they're both even. So if I divide by 2, on top and bottom, I get 5/24, which was actually the least common denominator, or lowest common denominator. So be careful on 94, you want common denominators before we add or subtract any fractions. We got like 5 more minutes. You want to leave 94 up or scroll back to the top? Alright, 90. Here, I'll take a screenshot of it so I can put it on the other screen.
Are you recording us?
Yeah.
Wait, is this recording us or is it your screen? No.
I'll show you in just a moment exactly what it records.
There's a little bit. That camera right
Alright,
there.
girl, I'll stop the recording.